Welcome to Tech Talk. The construction industry stands at a fork in the road, and the path it takes over the next few years will determine what the sector looks like for decades to come. According to Deloitte's 2026 Engineering and Construction Industry Outlook, the industry faces simultaneous pressures that could resolve in fundamentally different ways. Today, we're exploring three possible futures for construction, examining how current trends could evolve depending on which forces dominate. These aren't predictions, they're scenarios that help us understand the range of possible outcomes and what drives each one. Scenario 1. The digital transformation accelerates. In this first scenario, digital transformation succeeds beyond current expectations and fundamentally reshapes how construction operates. Let's explore what this future looks like and what would need to happen to get there. By 2028, AI-driven project management has become standard across the industry. The promise that digital tools can reduce project timelines by up to 20% gets realized at scale. Autonomous equipment moves from early deployment to widespread adoption. Construction sites look different. Fewer workers operating heavy machinery manually, more workers monitoring systems and managing digital workflows. Robotics handle repetitive tasks like bricklaying, welding, and concrete finishing with consistency that human workers can't maintain over long shifts. The workforce crisis that threatened to cost the industry $124 billion in lost output gets addressed through productivity gains rather than hiring more workers. Instead of needing 499,000 new workers, the industry needs 300,000, and those workers require different skills. Data scientists, digital engineers, and AI specialists become as common on construction projects as electricians and plumbers. Building information modeling combined with digital twins becomes mandatory for any significant project. Developers expect it, insurance companies require it, and clients demand the transparency and predictive capabilities these tools provide. Computer vision systems monitoring safety in real time become standard, and incident rates drop significantly. Construction becomes one of the safer industrial sectors, not one of the most dangerous. The data quality problem gets solved through industry-wide standards and robust governance frameworks. Companies that invested early in cleaning their data and establishing proper protocols gain massive advantages. But eventually, standardized platforms emerge that make good data management accessible even to smaller firms. What drives this scenario? Several factors would need to align. First, firms would need to overcome their historical conservatism about technology adoption. The current crisis mentality helps, but sustained commitment through implementation challenges is essential. Second, the technology itself would need to deliver on its promises without requiring years of customization. Third, workforce development programs would need to successfully retrain existing workers and attract new talent comfortable with digital tools. In this future, large firms that invested heavily in digital capabilities dominate the mega-project space. But mid-market firms that adopted focused digital strategies thrive in specialized niches. The construction industry's productivity, which has lagged other sectors for decades, finally catches up. Projects get completed faster, with fewer cost overruns and better safety records. However, this scenario has trade-offs. Employment in traditional construction roles declines. Some workers who can't or won't adapt to digital workflows get displaced. The industry becomes more capital-intensive, raising barriers to entry for new firms. Small contractors without resources to invest in technology largely disappear. Scenario 2. The constrained equilibrium persists. In this second scenario, the industry's current challenges don't get resolved. They become the new normal. Construction continues operating under persistent constraints, and the market finds equilibrium at lower volumes and higher prices. The workforce shortage remains acute through 2030. Despite efforts to attract new talent, only 7% of potential job seekers continue considering construction careers. By 2031, when 41% of current workers have retired, the industry simply operates with fewer people. Construction output doesn't grow even as demand does. The 88.2% surge in project abandonment activity wasn't a temporary spike. It became a permanent feature as the market cleared projects that couldn't justify new cost structures. Material costs stabilize at elevated levels. Tariffs remain in place, and the effective tariff rate for construction goods stays between 25% and 30%. Firms adapt through systematic approaches: strategic stockpiling, material substitution, domestic sourcing, and supplier diversification become standard practice. Tariff adjustment clauses become universal in contracts, making project costs variable and unpredictable, but protecting contractors from catastrophic losses. Digital transformation proceeds slowly and unevenly. Large firms continue investing and seeing returns, but mid-market and small contractors adopt tools selectively, if at all. The productivity gap between digitally advanced firms and traditional operators widens. Two tiers emerge: sophisticated firms serving premium markets, and traditional contractors competing for smaller projects on price. Data center construction continues booming through 2028, then plateaus as power infrastructure constraints become binding. The five-fold growth in data center power demand projected through 2035 gets throttled by grid capacity limitations. Some data center projects proceed, but many get delayed or relocated to regions with available power. This eases some workforce competition, but doesn't resolve the fundamental shortage. What drives this scenario? Essentially, none of the current challenges get fully solved. Workforce development programs help, but can't produce skilled workers fast enough. Digital transformation delivers benefits, but requires sustained investment that many firms can't afford. Policy changes around tariffs and immigration don't materialize or don't go far enough. The industry muddles through rather than transforming. In this future, construction becomes a constraint on economic growth. Housing shortages persist because building costs remain elevated. Infrastructure modernization proceeds slowly. Data centers get built, but not as many or as quickly as tech companies want. The economy adapts to reduced construction capacity, but it's a drag on overall productivity. This scenario's advantage is stability. The industry knows what it's dealing with. Firms that survive the initial shock can operate profitably within the constraints. But it's a lower growth, lower dynamism future, where construction punches below its potential economic weight. Scenario 3. The policy intervention reshapes markets. In this third scenario, government policies actively reshape construction market dynamics, creating outcomes that pure market forces wouldn't produce. This future depends on sustained policy intervention at federal, state, and local levels. Workforce development becomes a national priority. Government programs modeled on post-World War II vocational training initiatives channel young workers into construction careers through subsidized training, guaranteed job placement, and tax incentives for firms that hire and train apprentices. Immigration policies change to expedite visas for construction workers, recognizing that nearly 10% of the construction workforce is foreign-born and that immigration is essential to meeting workforce needs. The federal government addresses the workforce shortage as a national security issue, recognizing that data center construction, infrastructure modernization, and manufacturing reshoring all depend on construction capacity. Programs emerge that make construction careers as attractive financially and socially as college track alternatives. By 2029, the percentage of job seekers considering construction careers rises from 7% to 20%. Tariff policies get rationalized. Rather than across-the-board tariffs reaching 50%, the government implements targeted policies that encourage domestic manufacturing of critical materials, while allowing cost-effective imports of commodities. The effective tariff rate for construction goods drops from 30% to 15%, relieving cost pressures without eliminating domestic production incentives. Federal infrastructure spending, authorized through legislative packages containing billions for domestic development, gets deployed strategically to smooth construction demand. Instead of boom-bust cycles where too many projects compete for limited resources, government spending counter-cyclically, increasing when private construction slows, decreasing when private construction booms. This stabilizes the market and makes workforce planning more predictable. Regional governments address data center power constraints proactively. Instead of letting grid capacity limit construction, states with data center demand invest in generation and transmission infrastructure. Power demand growing five-fold by 2035 becomes possible because the infrastructure to support it gets built ahead of need rather than reacting to demand. What drives this scenario? Political will and sustained policy focus. Construction's challenges would need to be recognized as economic priorities rather than industry-specific problems. The CHIPS and Science Act's approach to semiconductor manufacturing would need to be applied to construction workforce development and supply chain resilience. In this future, the construction industry looks more like other advanced economies with strong construction sectors, better vocational training pipelines, more stable policy environments, and more strategic coordination between public and private investment. Projects get completed more reliably, costs moderate, and the industry becomes less volatile. However, this scenario requires something difficult in current political environments: sustained, bipartisan commitment to industrial policy. It also requires significant public investment, which competes with other priorities. The track record of government intervention in industry dynamics is mixed, sometimes successful, sometimes creating new distortions. The realistic outcome: elements of all three. The most likely future combines elements of all three scenarios, rather than following one path exclusively. Some firms will successfully digitally transform, while others won't. Workforce shortages will ease somewhat, but not disappear. Policy interventions will occur, but won't be comprehensive enough to fully reshape market dynamics. Large construction firms will probably experience something closer to Scenario 1, successful digital transformation enabling them to do more with less. Mid-market firms will likely experience Scenario 2, operating under persistent constraints and finding equilibrium at lower volumes. Small firms will be most affected by policy choices in Scenario 3. Their survival often depends on whether workforce programs and financing support materialize. Different regions will experience different scenarios. Areas with strong tech sectors and data center construction will see more investment in digital transformation and workforce development. Rural regions may experience persistent constraints with less policy support. States with proactive governments may implement mini versions of Scenario 3, while others operate under Scenario 2 conditions. The construction industry's actual future will be messier and more varied than any single scenario suggests. But thinking through these possibilities helps identify which forces matter most and where strategic interventions could shift trajectories. Closing. 3 possible futures for construction, each driven by different forces and producing different outcomes. The digital transformation scenario offers the highest productivity but requires sustained technological investment and workforce adaptation. The constrained equilibrium scenario is the path of least resistance, but limits economic growth. The policy intervention scenario offers the most balanced outcomes, but requires political will that's difficult to sustain. Which scenario seems most likely to you? Which one would you prefer? And what do you think would need to happen to steer the industry toward that outcome? Share your perspective in the comments. Subscribe to Tech Talk for more analysis of how industries evolve and transform. Thanks for watching.